Hi, everybody. Happy Thursday. Hopefully it's a little bit less gloomy than yesterday, and hopefully everything's going all right for you guys. I will tell you, you guys did an awesome job with your IXL yesterday. I know it might have been confusing at first, but hopefully after you kind of logged in, you gave it a try, you figured it out. For those of you that I spelled your names wrong when I entered usernames and logins, I'm so sorry. I felt so bad. I'm like, oh, that is totally my bad. So I apologize, but you guys were wonderful. I appreciate all of your questions, all of your feedback. You guys are great. Let me really quick just feature my dog. Boo Bear, say hi. Okay, well, it's actually not my dog. It's Scott's parents' dog. And new view for today, with the balcony in the background. Very exciting, I know. All right, so today it could actually be a review from 7th grade. I'm not totally sure what you remember or don't remember, or if you guys covered this in depth last year, but we're looking to graph linear inequalities on the coordinate plane. So our quick agenda for today, number one, we're going to look at coordinate pairs to see if they are solutions for inequalities. Number two, we're going to learn how to graph them on the graph, and I'm actually going to do it live for you so you can kind of see step by step what it looks like as if I'm in front of you in the classroom. We'll talk about your Thursday assignment, and I'll show you online how to do that. And then problem solving number 3, due by 11:59 tonight. Tonight. Do not forget to submit for me, okay? And then also as a side note for your homework, I had a few kids ask me if it was okay to submit assignments at like 10 o'clock, 11 o'clock. I don't care, you guys. That is totally fine with me. You guys know that number one, I stay up really late. And number two, if anything, I'll just check it in the morning. The 9 o'clock was more of a school, like Glenside guideline. But for me personally, that's totally fine. All good. All right, objective for today, you can graph a linear inequality, and we want to identify your solution regions, which we will do together. Okay, so let's say that you're given the inequality y is greater than x minus 3. And I ask you, does this coordinate pair serve as a solution for your inequality? Or does this one? All you need to do to see if it does or does not is plug in your x and y values to your inequality. So if I rewrite my original, remember that you can plug this in. So your 2 would go for your y, and then your 1 would go in for x, because you know coordinate pairs are x, y. And let's see if that makes it true. So we have 2 is greater than 1 minus 3. Is 2 greater than negative 2? The answer is yes. So because it is greater, okay, and this is true, that means that 1, 2 is a solution for the inequality. It is a solution. For this guy here, we're going to do the same exact thing. So we're going to plug in negative 7 for y, and we're going to plug in negative 3 for x. And then we're going to go ahead and simplify. Is negative 7 greater than negative 6? The answer is no. Negative 7 is more negative. It's not greater than negative 6. So because this is not true and it's false, that means that negative 3, negative 7 is not a solution for your inequality. This skill that you're doing right here is going to be really important for when we're graphing and for when we're shading specifically. Okay, so here we go. Here are your steps for graphing an inequality. 2 things you might want to do. Number 1, when I finish pulling down the gray screen and explain everything, you might want to quickly take a picture of it with your phone. Or number 2, you can be kind of writing alongside of me. Or maybe number 3, you just learn it right away and you don't need to write down anything because you guys are great. All right, so step number 1, you need to manipulate the inequality so that it's in slope-intercept form, meaning that y is isolated on the left side. If I were to ask you to graph this, this is just like graphing a line. You'd start with your y-intercept of 3, and then you go up 2 over 1. Okay, it's in slope-intercept form. I will show you that if you're given your inequality in standard and you need to manipulate to change it, I'll show you how to do that in this presentation as well, so don't worry. Next, you are going to decide the type of line to use. There are 2 types of lines. The first is dashed, okay, like a little dashed line. The next one is solid. If you have a less than or a greater than sign, you will use a dashed line. And the reason being, when you draw that dashed line, it shows that all of the coordinate pairs on the line are not solutions, they're not included, okay? If you use a solid line, that's because you've got a less than or equal to sign or a greater than or equal to sign. All of the coordinate pairs on that line are included. That's why it's a solid line. It shows that they're included. Your hint as well for that, when you see a sign like this, you see how you have like the little line underneath? That's your clue to utilize a solid line. All right, so we've got the 2 points plotted. You figured out what line you're using. Now you need to figure out how to shade. So here's what you're going to do. You are going to choose a coordinate pair that is not on the line. That's not on the line. That's going to be your tester pair. One of the best tester pairs you can use is 0, 0. Very simple to plug in and to manipulate. Let's say that you plug in 0, 0, just like we did here with 1, 2, -3, -7. If 0, 0 makes the inequality true and it is a solution, you will shade the region that includes that coordinate pair. So if you plug in 0, 0, and it makes your inequality true, like you're good to go, you're going to shade the region that includes 0, 0. However, let's say with your tester coordinate pair, you plug it in and makes the inequality false. You are going to shade the region that does not include that coordinate pair. So if you plug it in and it makes it false, you're going to shade the other region, the one that doesn't include that coordinate pair. And I'll show you that within the next few examples to kind of make sure that you understand. Okay, so here we go. We're going to start off with a very simple one. This is kind of like a special case. It says, is it in slope-intercept form? But right now it's just x is greater than 3. Remember when I'd give you a line like x is equal to 3 and it's literally just a vertical line? This is very similar. So what you're going to do is you are going to go over to where x is 3, 1, 2, 3. And it's literally just going to be a vertical line going through, but you need to look back at your inequality to see which line you're going to use. Because it's just greater, I know that it's going to be a dashed line. So here's what it looks like. Oh my goodness. Now you guys can see how old I am and how long it takes me to do this with my little mouse pad. Okay, now for the shading. If you have a special one like this, you actually don't even need to do a tester pair. It says x is greater than 3. You just need to shade all of your x values that are greater than 3. So this is not very fancy, but here's what it would look like. Okay. All right, moving on to one that's more at your speed, more what you guys are going to see. So it says y is greater than x plus 3. So step 1, is it in slope-intercept form? Yes, it is. So we are ready to graph. So let's go ahead and graph our y-intercept and apply our slope. So I know that I'm starting at 3, and then I'm applying a slope of up 1 over 1, up 1 over 1. We know our slope is 1 because there's no coefficient in front of x, so if you don't see a visible coefficient, we know that it is 1. All right, so here's what it looks like. Now, to that, what type of line are we going to use? Because it's just greater than, and there's no line underneath, we know that it's going to be a dashed line. So it's going to look something like this. Ooh, and let's pretend that that's straight to make Mr. Land feel better. Okay, so type of line is done. Now for the part of shading. So we need to test a coordinate pair that's not on the line. If you see 0, 0 is not on the line, your line's all the way up here. So let's use 0, 0. Let's plug it in to see if it makes it true. So when you plug it in, here's what you've got. Is 0 greater than 3? No, it is not. It is not greater than 3, so it's false. Therefore, we're going to shade the region that does not include 0, 0. So we'd only shade up here. If 0, 0 made it true, then we'd shade this guy down here because we know that 0, 0 is a solution. But because our tester pair made it false, we shade the region that doesn't include it. Okay, moving on. Let's say that I gave you this inequality. Hopefully you can detect that this is in standard form, not slope-intercept. So before we can do anything, we need to change it from standard form to slope-intercept form. So let's quickly review how to do that. We know that our goal is to get y by itself, which is what I highlighted here. Let's move 3x to the other side using inverse operations. So we know we're going to subtract 3x to both sides. Then we're left with 2y is less than or equal to negative 3x plus 2. Y is still not isolated though. Because 2 is being multiplied to your variable, you need to perform the inverse by dividing every single piece by 2. Okay, so notice I literally did it to every single piece of the inequality. And then here's what we have. It's just y is less than or equal to negative 3 over 2x plus 1. So now we're good to go. Now it's in slope-intercept form. So let's go ahead and plot my y-intercept. Sorry, this is taking so long. All right, so we're going to start with 1 here. And then I know that my slope is negative 1, 2, 3 over 2. 1, 2, 3 over 2. I've got 3 points on there, so I can pretty much connect with the line at this point. For the type of line, notice it's less than or equal to. You see that you have the solid line there. I know my line is going to have to be solid as well. So when I draw that in, let's pretend that that's straight. There we go. Okay, now to shade. Sorry, this is not the best line. Notice right down here, 0, 0 is not included on your line. So you can use it as your tester coordinate pair. So let's test 0, 0. When you plug that in for x and y, here's what you have. Is 0 less than or equal to 1? The answer is yes. Yes, it is. So because that makes it true, we will include 0, 0 in our shading. So if we shade, we want to make sure that we include the region that has 0, 0 because it made it a solution. It made the inequality true. Oh, do you like the Packers colors, green and yellow? And so that's what it would look like, only it'd be nice and organized and pretty and not like mine. Okay, last one. Let's say that I'm given y is less than or equal to 2x. Notice that you don't have a y-intercept, so where do you start when you're not explicitly given a y-intercept? We start at the origin. We start at 0, 0. So when we start here, then we're going to apply our slope of 2, up 2 over 1, up 2 over 1, up 2 over 1, and we can keep going. Now, it's less than or equal to, which means that I'm going to have a solid line going through. Oh, that one's a little bit better. Now, the last part is shading. 0, 0 is what I usually use as my tester pair. However, notice 0, 0 is included on our line, so we cannot use it. We could use literally any other coordinate pair, anything around here. I'm just going to choose 3, 0 because why not? So let's plug in 3, 0. It's for x and y. So you've got 0 is less than or equal to 2 times 3. Is 0 less than or equal to 6? The answer is yes. So because 3, 0 made the inequality true, we are going to shade the region that includes 0, 0, or sorry, 3, 0. So we would shade this whole region here. And then you're done. Okay, so if you have any questions, please message me or go back and rewatch the video. Your assignment for tonight, also side note, please look at Boo Bear. She was so cute helping to grade the projects. They were awesome. This is for my other classes. You only have one IXL today. You have T3. And I'm going to show you how to manipulate the website in a minute, just so you know how to graph. Don't forget, problem solving number 3 is due by 11:59 as well. Also, breaking news, I am officially verified on YouTube. Oh, big day, big day. I guess one perk of e-learning, so yay. Okay, so here's what your IXL looks like. If you were asked to graph the inequality x is less than or equal to 5, notice that my cursor has like a little circle here. I'm going to find where x is 5, which is right here. That's going to be a vertical line, okay, because you don't see a y. So that's what I have. Because it's less than or equal to, it does need to be a solid line, but let's pretend that it didn't. So you see how like when you move it and you hover, it gives you the dashed. If you click that, it changes to dashed. Or if you hover over again, changes to solid. So you're good to go. Now it says less than or equal to. So I need all of the x values less than 5. So hold your mouse down, go like this for a little bit, and it shades the whole region for you. Submit. Awesome. Okay, and then you've got x is less than -2, so I'm going to come over to -2, draw on my line. Oops. Notice it's less than, so I need this to be a dashed line, so I change that. Again, we want to shade the region that's less. I also really like the yellow. That makes me happy. Awesome, got it right again. And now you kind of start to get into ones that are more towards slope-intercept form. So this is kind of like the example I just showed you. Start at 0, 0, up 2 over 1. Okay, so then you have your line. I know it needs to be dashed though, because it's just greater than, and then you could plug in 2, 0 to test it out, 3, 0, etc. So I think that that's it, you guys. If you have questions about anything, please let me know. Please understand you guys are absolutely amazing and you're doing a wonderful job with e-learning. Your teachers are very proud of you. We talk about it all the time, how great you guys are doing and how impressed we are. So if you need anything, let me know. And tomorrow's Friday, so happy early Friday. All right, bye guys. Thank you.